Okay, this is a tutorial on how to project 3D objects onto 2D plane. So first of all, I'm going to show you a small animation. So over here, this grid is a surface in 3D, and this object is rotating about this axis like so. And there are many parts into this problem. First of all, how do you rotate the object in 3D? But the part that we are interested in is how do you project a 3D object onto your 2D screen. So let's clear that. So say your eye is at some coordinate, some x, some y. Well, we'll just actually the x and y are 0 0. So 0 comma 0 comma, and let's say that your z coordinate for the eye is zi. All right, so that's your eye, and your screen is like this. This is the origin of your screen. So this is actually the screen, right? It's perpendicular to this vector. Cool. So this point, that is 0 comma 0 comma 0. You could use some other points as well, but I'm just using that. And for more for more generality, what we could do is use some other z coordinate. So this could be 0 0 comma z screen, and this is exactly what I was doing. I was using some other z coordinate, not necessarily 0, so that we can plot relative to a certain point which is not necessarily having its z coordinate to be equal to 0. All right, then you have this object over here. So we won't be focusing on the whole object. Let's just focus on one point. First of all, how do you project this point with xyz coordinate onto our 2D screen? The way to do that is, first of all, you just draw this line from our eye to the point, and then every point on this line is basically perceived the same for our eye, right? And once again, here I'm using the word point and not just a small object. If this object actually has dimensions, then that's bad. This should be, in a truly mathematical sense, a point. Only then will your eye perceive all of these points to be the same. So then that means this point is also perceived the same as that point. So this point is what we are looking for. How do you get that? Well, first of all, you figure out what this point is. This is just 0 comma 0 comma z, right? You figure out what this vector is. This thing is just x vector, so it's just x comma y. That's what this vector is. And now you want to figure out this vector, and this can be done by basically scaling down this vector by a fraction of this length upon that length. And how do you get this fraction? That's just z screen minus zi upon z minus zi. So just multiply by this fraction, so multiply this vector by that fraction, and you will get this vector. So we'll just call this x dash comma y dash. And so basically you have figured out where your position should be on the screen. So just 0 comma 0 comma z screen plus this thing, that's this point, but we'll forget about the z screen completely, and we'll just say that, yeah, with respect to the screen which doesn't know what z coordinates are, x dash comma y dash is basically this point. And there you have it. Now you have projected a point in 3D onto your screen. Now it's time to go to a full-fledged object. So the object that we are talking about is made up of a bunch of points which are interconnected by lines in a certain fashion. So our object looks like a cloth if somebody folded it. So it has these things, what do we even call that? I don't know, but it's like a cloth. So these connections over here, those are between two adjacent points, and every point can have 4 adjacent points, except of course the pointed edges. All right, and every point will be transformed to a certain point on your 2D screen, and then you just redraw the lines. So these are lines, these are not curves. All right, so you redraw all those lines on your screen, and there you go. You have a projection of this whole object on your screen, which looks like it's in 3D. although not really. Right, so that's it. I'll see you guys in the next video.